starting now. And we're getting ready to move on to our next topic. Today we're going to do prefix, postfix, infix. So if you want to grab your packets and we'll get ready to talk about prefix, postfix, and infix. I'm going to switch cameras. All right, some of you yesterday, sorry about the background noise. Somebody needs coffee. Yesterday in 162, we were working on doing our introduction to binary search trees. Some of you have already had 162. Some of you are in it now. Some of you not yet. But the topic that we got to talking about was how to traverse through this tree. And what the tree looked like was something along the lines of, and I'm going to start with a simple expression, because whenever I need to come back to learning prefix, postfix, infix, I always start with something as simple as 4 plus 2. And when I represent that in this thing called a binary tree, I have the 4, the plus, and the 2. And these are, in fact, a couple of nodes that we're talking about. We have a node for the plus, we have something to the left and something to the right. So what we're going to talk about today is something called prefix, infix, and postfix. Okay? So we have these three things. Now, whenever I get ready to look at infix, that means the operator is in the middle. So I would have 4 plus 2. So I'm going to start to refer to this as the node, this as the left of the node, and this as the right of the node. Now, eventually you'll see that the 4 and the 2 are going to become nodes as well. But for now, we have a left and we have a right. So if I use the L, the N, and the R, and I talk about something called infix, it's going to be simply the left followed by the node followed by the R. This is going to give me the 4 plus 2, which is what we're used to seeing all the time. All right. Prefix is one where the operator comes first. So it's going to be the plus, then the left, then the right. So it's going to be node, left, right to give me plus 4, 2. And you see how the operator is in the beginning, hence the term prefix. And then finally, postfix is left, right, node, 4, 2, plus. And some of you are familiar with stacks. And this was an advantage of working with stacks. Questions? And again, this should be familiar to a lot of you. We talked about the traversals being the left, right node and the left node, right. And we want to keep that in mind. Now, I could do this, and it would give me the same answer as plus 4, 2. Everybody agree? They would both evaluate out of 6, but I don't want you doing that. I want you to keep the left and the rights in order. So if I have a giant expression, I want to see the numbers in order. The only thing I want to see moving are the operators. Okay, so if we take a look at the packet, and hopefully some of you have it in front of you, you start to see some expressions, and we're going to work on how do we make these left, right nodes, these prefix, postfix, infix expressions. And the one that we start with at the top is A minus B over C plus D. Minus C over, well, that's B, excuse me. B over C plus D. That's a pretty B, isn't it? We can give it antennas. Make it a B. Somebody laugh. Nobody laugh. All right, so you see, and in your world of computers, you know this now has to become A minus the quantity B divided by the quantity C plus D. And you see that on the paper above, right? So we're going to take a look at how can I turn this, what currently is in infix, into one of the other ones. How do I turn infix into prefix? How do I turn infix to postfix? How can I move around from one way of representing this to another? Some of you are saying, well, this is kind of boring. What am I ever going to use this for? And some of you already know the answer to that. In 162, we saw an example of how we can do expressions. so that the computer can handle that using stacks. We looked at a couple of other things. All right, so now I got something nice and long. I need to go back and try something simple. So I'm going to do 4 plus 6 times 5. I'm going to do 4 plus 6 times 5. And what I want you to do is, can you turn that into a binary tree like you see above? I'll start with the first one. If I look at this, my operators, the first thing I'm going to do is the multiplication. Second thing I'm going to do is add 4. So far, so good. I'm going to start with the multiplication, make it a node, a left, and a right with the 6 and 5. Once that's calculated and I have that answer, I would like to take that and add 4 to it. So now I have 4 plus this side. This side is the 6 times 5. Everybody still with me?
Yeah.
Yep.
Okay. So by making this tree, it's going to really help me to go back up above and convert what right now is an infix to one of the other ones. Okay. Another practice, 4 plus 6 times 5. What's that going to look like? Well, what's my first operator? Well, the plus is going to get done first. Here's the 4, here's the 6. So it's like I'm building as I go up. This being my first operator, this being my second. Then I'm going to multiply that result times 5. Okay, so as you know right now, these guys are both written in infix. And what I'd like to do is turn this into prefix notation. And then I'm going to turn it into postfix notation. All right, prefix. What did I say prefix was? Well, up above, we wrote prefix is, it's going to be the operator first, then the left, and then the right. So prefix, node, left, right. So I'm going to come on to this guy, and I start here, and is it a node? The answer is yes. So it's going to be plus. I went node, then left. Now, when I came to the left, it actually is a node. So I'm going to write the 4. Once I'm at this node, I look for a left. Is there a left? The answer is no. Is there a right? The answer is no. So I took care of, I started with the node. I went to its left. It became a node. I checked its left. I checked its right. It's done. So now I go back up to this original node and I want to do its right. When I come to its right, the first thing I see is multiplication as a node. I check its left. Oh, it's a node. I write the node. Does it have a left? No. Does it have a right? No. So I work my way back up. And now I say, go to the right. It's a node. I put the 5 down. I check its left. I check its right. I think I'm done. What's going to happen is you're going to find faster ways to do this instead of having to draw the tree each time. But this first time, we're going to spell it out. All right, somebody try the postfix. Tell me what you get.
Is it times plus 4, 6, 5?
Times.
Oh, sorry. No. Sorry. I'm doing the prefix for the other one. My bad.
Okay.
4, 6, 5 times plus.
Okay. Let's double check it. The 4, the 6, and the 5, still in the same order with all of them. The only thing that's moving is the operators. So I'm looking at 4, 6, 5, an operator. So now I'm going to take the 6 times 5 and get to 30. Then I have 4 plus 30, 34. I think that's good. Everybody else good with that? All right, let's move over here. What's the prefix going to be? Comb, you had it?
Times plus 4, 6, 5.
Times plus 4, 6, 5, which means these 3 would be done first, the plus 4, 6, And then that would be my left multiplied by 5. I think that looks pretty good. This is one of the better topics. It's a little easier. Sircott, you made it.
I did make it.
Good.
Had to make some coffee.
Yeah, the coffee pot just disappeared from my kitchen and went down to another person working. Postfix. Let's see. In Postfix, it was left, right node. So I start here, I go to the left, I go to here, I go to the left, I get the 4. Then I go to its right. Then I go back up to the node. So I took care of the left. Now I'm going to do the right, which is just 5, and then go back up to the node. 4, 6 plus 5 times. You good?
Yeah.
Yes.
Okay. So from the previous page, I'm now going to copy this over. We have A minus B divided by C plus D. That is in fact infix. We have some parentheses going on there and oh boy. All right, let me ask you this time. What operator gets done first? To me, it looks like the plus, right? I'm answering my own questions, which is a teaching faux pas. You ask the students a question, you wait for them to answer, because if you answer it, then they're never going to answer it. You're just going to sit and wait because they know you're going to answer it. What operation would get done second?
Division.
Division, and then finally?
Subtraction.
Subtraction. So if I'm going to do this in prefix, I can either A, draw that tree again, or I can start out here on the right, and I want to make this prefix. So I'm going to say right here, plus CD. Okay? Now, that becomes its own thing. It becomes a right, basically. So what do I have? My second operator is a division. So it's going to be divide, left, right. Divide, left, and then that's my right. Now this whole thing becomes a right. And here's my left. I'm doing prefix. So minus the left and then the right. So another way to do it other than drawing the tree would be to do what we're doing right now. And the more you look at them, the more you might get. If I did the tree, it would be C plus D, B divided by, and then finally A minus that guy. So you have to pick one you like and go with it. What about postfix? So the C plus D goes first. How do I write that in postfix?
CD plus.
CD plus. Then I have that. My second operator is division. Who do I put where?
B divide after the plus.
Put the divide over here.
Or
And
the
put
B
the B,
before it.
the B before, right? Because this is like the new right, the CD plus. So this is the left, right, and then the operator. And last but not least,
A minus on the other
here's
side.
A. And where's the minus go?
After the division.
After the division. Good. Questions? So far, so good. Postfix has another name. When you move on after me, Polish notation, reverse Polish notation. Just throwing that out there as an FYI. Okay. Flipping to the page of problems. You all have these. Let's pick a number. Let's do a couple of these and see what we have. Pick a number, any number.
13.
13. 13. Solve for x in the equation. The equation is in postfix. So what are we going to have to do with that equation? Convert it to infix, right? All right, so let's see what we have. Number 13. I'm looking at x1 minus x divided by 1x3 plus / 2 equals. Double checking to make sure I copied the problem down right. I think I'm good to go. All right. So what do I want to do? I want to start identifying. This guy is in postfix. So I want to start identifying groups of 3. For example, x1 minus. Those guys kind of look like they go together, right? So now this becomes its own thing. Here's a group of 3. This x1 minus, then an x, then a division. Here's a group of 3, x3 plus. Here's a group of 3, 1, and this with the division. Then I have this square box, and a division. Squigglies going all the way around. Scooby-doo-ba-doo-ba-doo. And then I have this squiggly box, the 2 and the equals. So it looks like in the end it's going to equal 2. So let's see what we have. Inside of here I go x, let me go back to something darker. X minus 1 divided by x. So far so good?
Okay.
What's the next term? Here. What does that become?
X plus 3.
X plus 3 divided by
1.
1. What's between the square box and the square box? A division sign. And then the squiggly equals 2. And now you have to use your great algebra skills and solve this. That's a 1. Divide is the same as multiply by the reciprocal. I get that kind of thing going on. Algebra skills. What's next? Clear the denominators. Don't make me start calling on people. Leah already talked, so coming down my list. Adam, what do I do next?
Still working through it.
Brian, what do I do next?
Multiply across.
Yeah,
Multi-
I'm going to multiply everything by what? An x and an x plus 3.
Yeah.
So when I'm going to multiply by an x and an x plus 3. First guy is going to give me x minus 1 times x plus 3. Wait a minute, I'm not adding. I don't.
Yeah, no, it's multiplication. You go straight across.
Yep, thank you. I was doing adding. X times x plus 3 equals 2. Jeez, who picked 13?
Negative 1/4 and negative 9/4, right?
I get 2x squared plus 5x plus 1. Are we there?
Yeah, and then it's once you do quadratic, right?
Okay, so I'm at negative 5 plus or minus b squared minus 4ac, which is 8, all over 2a, which is 4. Negative 5 plus or minus the square root of 17 over 4. Or did I mess that up too?
Oh, I messed up.
Oh. Anybody else get that?
Did once I correct myself, so
Okay.
More or less.
Nice job, Jake from State Farm. Pfeiffer, pick a problem.
$18.
18. Holy cow. 18. I have A equals 5. B equals 1. C equals 25. D equals 2. And E equals 3. And I have caret plus slash plus ABC slash times CD plus ED divided by BD. Caret plus slash plus ABC slash times CD plus ED slash BD. I'm looking at groups. There's a nice little group of 3. There's a group of 3. There's a group of 3. And there's a group of 3. We okay with that? I'm looking at slash all of that, and I'm making a group because that's an operator, a term, and an operator. I'm looking at slash followed by these two terms. I'm now going to take this term and this term and add it with my squigglies. And then I'm going to take that thing and raise it to the B divided by D power. Holy cow. Anybody have a different way to do this? Or are you just following along right now? All right, so I'm looking at A plus B divided by C. I'm looking at C times D divided by E plus D. It looks like I'm going to add those two things. And that whole thing is going to be raised to the B over D power. Somebody check my work.
Looks good to me.
A plus B
6.
over
25
plus
uh,
27.
50 over 10.
I think that's multiplication, C times D,
50
50.
over 10.
50 over
10.
that one's a plus.
Oh,
5.
7.
Raised 5, raised to the
1/2.
1/2. Oh, let's see what we have. 6 over 25 plus 10 raised to the 1/2 power 10 is how many 25ths? I'm going to get a common denominator here.
150.
I like it when a plan comes together. 250 plus 6
256.
over 25 to the 1/2 power gives me
16 over 5.
right, or 3 1/5.
So on the tests, are we gonna bust out our algebra skills, or is it gonna
Maybe.
be simply?
Maybe you guys just picked the hardest two, I think.
We're gonna have to type in latex also, so you guys better get on that.
You're going to have to type in latex.
I guess you could use text.
Yeah. Yeah. I'm thinking the same thing. Yeah. Yeah, because we're going to have to be typing these in. Yeah. You'll be able to skip some steps. And I'll have to look at the problems I'm giving you to minimize some of the typing. Who else haven't I heard from? Justice, pick a problem. One more and then we're done.
2.
Number 2.
Yep.
All right. Maybe 2 more and then we're done. Convert the following postfix into prefix. Number 2. A, B times CD plus minus E slash. Whenever I do these, I've screwed up enough that transferring them over to paper, I've made mistakes. So I've always gotten into a habit of double checking that I make sure I type them in right. All right, I have it in postfix. I want to go prefix. So I'm looking at my grouping. There's a group. There's a group. There's a group. And then what's left is a group. So the first thing I need to do is get this to infix, and then I can finish it up by putting it in postfix. What you got?
A times B.
A times B
Minus C plus D.
All over E.
Yeah.
Now, I wrote it that way in our computer world instead of writing it in fractions because I'm going to want to leave it this way to do my next conversion.
That's
So
probably a good idea.
let's make it pre. What gets done first? What's my first operator?
A times B.
Yeah. Second operator?
C plus D.
Third?
Then the subtraction.
And fourth?
And
Division.
The E. Okay. Let's take care of the first one, making it prefix. Don't turn around and make it post again. Prefix
Plus AB times AB.
times AB. Second
Plus CD.
plus CD. Third
Minus all of that.
minus all the way in the front. Because these three are together, these three are together, the operator's in the beginning. And then finally, fourth, this whole thing,
divide E.
Division in the beginning. Then
division in the
E at the
beginning
end.
and an E at the end. Good.
Yeah.
Gotcha.
Good. Not so bad. All right. I promised you one more. That one went quick. That's more what you're probably going to see on the test. mean, that tells me if you know what you're doing or not. Who's somebody I didn't hear? Mo, are you here?
Yes.
Pick a problem.
Number 4.
Number 4. Find all integral values of x, which makes the following prefix expression has a value of 0. Number 4 times 1 plus x2 minus 7x. I'm going to take these guys together, these guys together. I'm going to take these guys together. Anybody else get that?
Yep.
1 times x plus 2.
Yep.
Yes.
All right. That times 1 doesn't do much for me. X plus 2 times 7 minus x equals 0. Seven x minus x squared plus 14 minus 2x equals 0. Still right?
Mhm.
Negative x squared plus 5x plus 14. What you want to do now?
I mean, couldn't we have just left it in the x plus 2 times 7 minus x and then solve like that?
I was waiting to see if somebody would stop me or not. Yeah, x equals negative 2, x equals 7. I was just having fun. Questions, comments? Okay, on Monday, we're going to jump into chapter 11. We're going to spend some time there, then have a test on 10 and 11. Probably after that test is when we'll do our last 2 topics. We'll be able to do those in one day. That'll be recursive functions and assembly. And then we can have the test on the selected topics. Anybody have any questions on the Boolean algebra or the digital electronics or the computer number systems or any of those? If you do, come to a class, to start with it, and we can always do extra problems when we need to.
When did you say that test was?
We don't know yet.
Okay.
So we're going to spend the next 3 classes doing chapter 11. So that'll be Monday, Wednesday, Monday. And then by either Wednesday the 8th or Monday the 13th, we will have our test on chapters 10 and 11.
Okay.
Okay. But for now, all you need to know is we're starting chapter 11 on Monday.
Sounds good.
All right, everyone. We still have time, but I think we're good. We're going to stop here. And if you want to practice some more of these on your own, you're more than welcome to. So if no other questions, I'm going to cut it off here and stop the recording.